Second part of block day, we were practicing putting numbers accurately on the number line. So number line is just like a ruler, just like a meter stick, something that we've definitely had to use once or twice in our lives. And it helps us understand the overarching idea. So I'm going to put 0 right here in the center. 1, 2, 3, 4, 5, 6. And then over here we have the negatives, -1, -2, -3, -4, -5, and -6. So in between every whole number is a whole bunch of decimals. So we kind of like to think about the number line a lot like money. So starting right here, you have $0.00. You get to $1 right here, you got $1.00. $2.00, $3.00. So far, then this way it's -$1.00, -$2.00. In between are all those little pennies that we typically don't deal with in our day-to-day lives because we usually just use like debit cards and whatnot. But between $0 and $1, we've got 0.5 or 50 cents. Halfway between these, 1.5, 2.5, 3.5, 4.5. And then the little tiny notches that I've included on this number line, this would be like 2.25, $2.25. The reason why the number in front right here is 2 and not a 1 is because we've crossed over and we have 2 whole dollars and then part of the next dollar. So this one right here, that'd be $3.25, $3.50, $3.75, so on and so forth. The negatives is where we could get tripped up a little bit. In between, we still have like -1.5, but this first notch is -2.25. It's the mirror opposite of the positives, where positives and negatives are considered opposites. We're going the wrong direction. So 0.25, 0.5, 0.75, 0.25, 0.5, 0.75. 25, so 25 cents, 50, 75. 25, 50, 75. So I'm going to throw in -3.75 for this one right here. So knowing these little benchmarks right here actually help us plot a lot of different decimals. So if we start with a number that's already in decimal form, let's say 2.37, I'm saying that I have 2 whole dollars and then 37 cents of the next dollar. So I have 2 whole dollars, 37 cents. So here's $2.25, $2.50. So I'm in between these two marks, and I'm actually probably pretty close to being halfway. There's 2.37, like that. When the number's already in decimal form, again, it's quite easy to plot. -4.57. So I have -4 whole dollars. So I'm at least here. Then here's -4.50. So I'm a little bit beyond that, but I'm not quite to 75. I'm probably more like right here. So we take the first number, and that tells us which whole number we need to pass. So we're between 4 and 5. So I'm going to do one last one. Get rid of that one. Let's go with $5.83. So 583 is between the whole number 5 and the whole number 6. So I'm over here. It's bigger than $5.50. So it's past that. And it's bigger than 5.75. So it's somewhere over here. So $5.83 right about here. One last way that you can kind of visualize a number line if it helps you, because decimals can sometimes be kind of tricky. I'm going to kind of erase what we have. Actually, I'm just going to go to my next page, drop another number line. Is decimals are really just bigger numbers with decimal points. And I know that might sound like, well, duh, it kind of looks like them. So 0, I want to think as triple zeros. 1 as 100, 2 is 200, 3 is 300, 4 is 400, 5 is 500, 6 is 600. Now we technically, if you want to go back, we have those decimal points, but we're not going to worry about the decimal point here. So in between, that's 150, 250, 350. So when I want to plot the number 3.7, let's go 3.6, 3.61, you can really think of this as 361. And where do you find 361? Except for right there, above 350, but less than 375. Now on the homeworks, we also have to place fractions. So if you have to plot the fractional number 2/5, it's helpful to convert that into our decimal by doing long division and plotting it based on that. Same would be for non-perfect square roots. Watch those videos if you need some tutorial on converting fractions to decimals or non-perfect roots into decimals.